In this video, we will be discussing the low-level design of the classic board game Snakes and Ladders. Let's start with the requirement gathering. First, the game should support multiple players. Second, the size of the game board should be configurable. Third, players will set the number of dice used at the starting of the game. Fourth, the board also contains some snakes and ladders. Fifth, each snake will have its head at some number and its tail at a smaller number. Sixth, each ladder will have its start position at some number and end position at a larger number. Based on the requirements, we have the following entities: snake, ladder, player, dice, game, and board. Let's look at the code for each entity along with their relationships with other entities. We will follow the bottom-up design approach by starting with the smallest unit in the system. Starting with the mover class. This is an abstract class representing a common base for both snakes and ladders. It contains properties start and end, indicating the starting and ending positions of the mover. We have two classes that inherit from the mover class, which represents the snakes and ladders in the game. First, we have the snake class, which is a perfect representation of the obstacles in the game. Just like a real snakes, this class has a start and end position indicating where the snake begins and ends on the board. The constructor initializes these positions, allowing us to customize the snake's placement on the board. Next up, we have the ladder class, which is the complete opposite of the snake class. Instead of being an obstacle, it represents a way to move ahead quickly in the game. Just like a real ladders, this class also has a start and end position, indicating where the ladder begins and ends on the board. The constructor initializes these positions, allowing us to customize the ladder's placement on the board. This design is highly extensible, meaning that we can easily add any kind of mover in the future, such as teleports or traps, by simply creating a new class that inherits from the mover class. Now let's see the player class, which represents a player in the game. The player class represents a player in the snakes and ladders game. It has three properties: ID, name, and current position. The constructor sets the initial current position to 1. The class also includes a method called setCurrentPosition, which allows the player's current position to be updated. The dice class represents the dice used in the game. It has a property called totalCount, which indicates the number of dice used. The roll function simulates rolling dice. It initializes a total to 0, then loops the number of dice specified. Inside the loop, it generates a random number between 1 and 6 for each die and adds it to the total. Finally, it returns the total sum of all the dice rolls. The board class is an essential part of the Snakes and Ladders game, representing the game board itself. It has two properties, size and movers. The size represents the total number of squares on the board, while the movers is a list that holds all the snakes and ladders on the board. The board class constructor initializes the board size and creates an empty list of movers. Additionally, it provides a method called addMover, which allows you to add snakes or ladders to the board. This Java code snippet defines an enum called GameStatus, which represents the different states a game can be in. The enum consists of three constants: not started, in progress, and finished. These constants define the possible states of a game. By using an enum like GameStatus, developer can easily manage and track the status of a game in a structured way. The game class represents the overall game and contains properties for the board, players, dice, and game status. The constructor initializes the game with a board, list of players, and dice, and also initializes the game status to not started. The game class provides a method called startGame that begins the game, and it can also provide other methods for managing the game state, such as checking the current game status or pausing the game. By having a separate class for the board and the game, it becomes easier to manage and modify the game's components. This design allows for greater flexibility, making it possible to add new features or components to the game in the future. The status field can be used to track the current state of the game, such as whether it is currently being played or not, and can be used to determine whether certain actions are allowed or not. For example, the start game method may only be called when the game status is not started, and other methods may only be called when the game status is in progress. In this Java code snippet, we have a GameRunner class with a main method that sets up a simple game scenario. Here, a board with 100 squares is created and a list of movers is initialized, which includes snake and ladders objects that define certain movements on the board. Each mover is then added to the board to influence player movement. Next, players are created with unique IDs and names such as Alice and Bob. Finally, a game object is created with the board, players, and dice. The start game method is called to begin the game. This code simulates a basic game setup where players move on a board with the help of snakes, ladders, and dice rolls. Provide a simple and fun way to understand how different components interact in a game scenario. Now let's see the has-a and is-a relationships. The board class has a relationship with mover objects which represent the snakes and ladders on the board. The board class contains a list of mover objects to represent the snakes and ladders. The game class also has a relationship with the board class as well as with player objects and a dice object. The snake class and the ladder class both have an is-a relationship with mover class, as they both extend the mover class. This means that they inherit the properties and methods of the mover class and add their own specific properties and methods. Thanks for watching. Don't forget to like and subscribe for more programming insights.